here that the basicity depends on that how strong bonds they can form with the hydrogen there. That is the reason I said basicity is a thermodynamic property, whereas the nucleophilicity is a kinetic property. Remember that, I repeat again, that always in a group from top to bottom, basicity is decreasing but nucleophilicity is increasing, and both of them are decreasing in a period from left to right. Okay. Now let us discuss about some of the trends in nucleophilicity. The trends in nucleophilicity. Trends in nucleophilicity. Trends in nucleophilicity. And most important relation I want to give you here is that if any species is carrying negative charge, it will have the more nucleophilicity than the corresponding conjugate acid there. Suppose if you take up OH minus will have more nucleophilicity than the corresponding conjugate acid. What is that? H2O. Then SH minus will have more than that of the H2S. Of course, this is also a nucleophile, but it is a neutral nucleophile. So generally, the negatively charged nucleophiles will have more nucleophilicity than the corresponding neutral nucleophiles, and this is NH3. There is one lone pair of electron. So what is the statement I can give here? That the statement is that always a negative nucleophile has more nucleophilicity than the corresponding neutral conjugate acid. Remember this point. Okay, always this will help you in finding the relative nucleophilicities of different nucleophiles. It is very important thing in the organic chemistry there. Okay. Right, one more point I would like to clearly tell in the trends of nucleophilicity here. It is a very important point. That is the second point I am going to discuss, that due to steric hindrance, what we find is that due to steric hindrance, as the number of electron releasing groups increases, electron releasing groups increases, nucleophilicity decreases. Now let me tell you, this point is a very important, that if you take up methyl CH3 minus, okay, I will take CH3 CH2 minus, okay, I will take another one is CH3, okay, I should take up here that the negative charge is on the oxygen there, okay, and all alkoxide ions I am taking up there, CH3O minus, CH3 CH2O minus, then this is CH3 and this is CH3O minus I am taking up here. Now as the bulkiness of the carbon groups increases on the oxygen, what is happening there? The nucleophilicity is decreasing. This is what happening to the nucleophilicity. The nucleophilicity is decreasing as the bulky groups are increasing there, because they are not allowing the oxygen to attack on the carbon easily because of steric hindrance there. So from left to right, nucleophilicity is increasing there. Nucleophilicity is decreasing here. Right? It is decreasing. Nucleophilicity is decreasing. But what we find is that from left to right, the basicity is increasing here. the basicity is increasing, because basicity depends on how easily they can form bond with hydrogen there. So hydrogen does not have any hindrance there. It is a free atom. That is why there is a little effect of steric hindrance is involved on the basicity, because it involves attacking on an unhindered proton there. So that is why basicity is increasing. Reverse to this. From left to right, basicity is increasing there. So it is because that nucleophilicity is measured how easily this group can form bond with the carbon, but basicity is measured how easily these groups can form bond with the proton, which is unhindered there. That is why when you want any nucleophile to act as a base, then we will take up that one which is having the very bulky alkyl groups there. And anything, if you want to act any nucleophile, you want to act as a nucleophile, then we will take the less bulky, that nucleophile which contains the less bulky alkyl groups there. Okay, so what is the conclusion here? The conclusion here is not that if nucleophile need to be act, nucleophile need to act as a base, we take that nucleophile which contains more bulky groups. If nucleophile need to act as only nucleophile, not as a base, only nucleophile, means it wants to form the bonds with carbon there. What I mean to say that we take that nucleophile which has less bulky groups, that which is having less bulky groups. Okay, now we have discussed about the nucleophiles and the trends in nucleophiles. What is the difference between the nucleophilicity, basicity, we have understood in today's class. In the next class we will continue this GOC 2, and where we are going to discuss about the different types of bond cleavages, electronic effects, and so on. I hope that you understood this class. See you in the next class.